Today IMCCRT 2023. I'm going to present on voltage oriented control Vienna Rectifier for electrical vehicle charging. So as you go through my subject, it clearly defines electrical vehicle charging station on which Vienna rectifier we are going to use. Before proceeding ahead, first we should know the electrical vehicle, how electrical vehicle works. Thereafter, thereafter how charging takes place and what is the station. So electrical vehicle is nothing but vehicle which works on electrical power rather than conventional types of fuels like petrol and diesel. This clearly defines that electrical power we can't carry on road. Obviously this can be carried by storing the electrical power through batteries. So in this case, electrical vehicle, the batteries are clearly used. They either may dry cell, lithium ion cell or any type of battery cell. So for that charging must be there. So vehicle on which electrical works, it is nothing but electrical vehicle. Thereafter, the bat, thereafter the battery which is used in this case, that means the battery used in electrical vehicle should be effectively charged, effectively stored and effectively work. So before proceeding ahead, we go through the basic diagram of electrical vehicle. So this one is the basic picture of the electrical vehicle. See here, electrical vehicle consists of charging basic part, that is electrical motor, thereafter electrical battery pack, thereafter a charging port, battery set, thereafter controlling unit and DC power converter DC to AC which required for charging, and then later on charger for battery which are used during running condition or working conditions. These part consist of electrical vehicle. Thereafter, these are arranged in this manner, this fashion manner. These are the wheels in which here consist of drive, or we can say DC motor. This one is nothing but a storage storing power, that is battery set. Thereafter, this one is a sitting arrangement, and this one is layer, protective layer, safety layer, and this one is the last backup arrangement, backup battery storage arrangement. Let us see, this one is the basic cell arrangement, and which base floor, it clearly shows these are the number of cells arranged in different fashions in parallel and series manner. This one is the base. Now, in this electrical vehicle, there are two types of variants. We can say in the initial stage, in electrical development of vehicle, initially one thing is completely electrical base and partially electrical base. Partially electrical vehicle is nothing but hybrid, in which partially it works on diesel and partially it works on electrical charging, electrical battery set we can say, and remaining another one is purely electrical. As I previously shown, this type of vehicle is nothing but purely electrical vehicle. So current phase is the developing phase, in which hybrid we can't directly shift to the completely electrical vehicle, because there are limitations of development of charging stations, limitations of effective battery and vehicle drive development, which may currently creating difficulties. That's why electrical vehicle can't be perfectly 100% effectively used nowadays. The current phase is nothing but a scrapping phase, in which diesel and petrol vehicle are going to scrap in phase-wise manner, and slowly developing of charging station, and thereafter completely. This may takes lots of time. Now this one is the battery cell arrangement, we can say it is nothing but a lithium ion battery cell in which positive and negative plate, on which copper and other plate is positive negative used, and they are arranged rotated in this way, and these arrangement are kept in roller in this like cell. This we can say as a cell. This number of cells consisted in this manner. In this way, these are arranged in nothing but here is a I have shown a cell in this way. It is nothing but arranged in this way. So now we are proceeding ahead. This lithium-ion battery cell is nothing one of the best output giving cell. Generally, lithium-ion cell gives 3.4 volt, 3.4 output volt up to maximum. Other than later ferrous is lower voltage, which we can say 2.8 volt. So we have discussed the proposed system of uh, novel Vienna rectifier. Now we are directly go to the uh, extension system. In the proposed method, we have utilized proportional plus integral controllers. Uh, Here, proportional plus integral controllers are used. Proportional and control integrals are used for uh, obtaining the stability, either in normal stability or transient stability. Uh, as the as in this system, the harmonics are reduced. That is, which is so-called THD, total harmonic distortion, is completely reduced, and these ANFIs may mitigate harmonics that obtain because of distortions in the current and voltage waveform, making by system ripple free. That means this is ripple free, generating output voltage as a ripple free. So we can attain good power quality and good speed response. So this is the recent extension or recent addition development, we can so call it. So we proceed further, working or a block diagram of the Vienna rectifier. So Vienna rectifier, or we can call it as a charger of vehicle. Um, so block diagram. This one is the block diagram of Vienna charging power station. This is called block diagram of proposed rectifier. These are the input sources, three-phase AC system. These are the resistors in order to relate the change in current or variations, and inductors change in currents. These are the diodes, that is D1, D1, D2, D3. This one is D1, D3. This one is D4 and D6. This one is D5 and D2. And these are the nothing but Vienna rectifier. Vienna rectifier. Uh, these are nothing but IGBTs, or we can say MOSFETs. MOSFETs, metal oxide semiconductor free transistor. So this one is the block diagram of. So this is the Vienna. This is the rectifier. This one is load. This one is voltage sensor in order to control. In this system we are using PI controller for inputs, feedback system. In order to get the feedback, this one is the voltage sensor which gives inputs to the controlling system. This one is ADC, analog to digital converter, we can say A to D converter or analog to digital converter. This one is the output is analog. We need to convert it into digital, and thereafter this one we can say as a proportional plus integral controller. This one is the control system block. This shows the control system block, and this one is voltage and current sensor. Voltage and current sensor, which give inputs to the controlling unit. Okay, so basically this block diagram, this system works on 3 modes. This works on 4 modes. Mode 1 is nothing but we can say MOSFET is off. During positive input. We send input during this cycle. The MOSFET is off. In this cycle, the current flows through this way. This fashion. This is called positive cycle MOSFET off, as this cycle is not conducting, the current is flowing this way. In another case, MOSFET is same off but is in negative cycle. We can call this as this way. It is called it as a MOSFET is off for input current positive, and MOSFET is on. Another one is condition MOSFET. Now you can check the conditions another which MOSFET is on. So in this case, current is this way. Both diodes are not conducting. This is called input current negative, MOSFET on. Another condition so called this diode is conducting, MOSFET is off, called mode 4, in which only diodes are conducting, MOSFETs are non-off. That is mode 4. Hence total there are 4 mode of working, and in this modes of working, I will go through the mode 1 when reference voltage is positive and cycle and controlled IGBTs are off conditions. Diode D1, that is diodes D1, this we can say diode this one is conducting this fashion. It is mode mode 1. This current flows through VRLD, LDC, reference shown. The in mode 2, the cycle switches in mode 2, cycle switches S1 and S2 are operating and non-operating in. So this works on mode 4. In mode 4 operation, when references voltage is negative half cycle, what already I have explained the mode 4 operation, in which this fashion manner conducts. This is called mode 4, in which of condition. It is after that Vienna rectifier applicable for in this scenario the application is for high power such as welding sources, wind energy generations, wind energy conversion system, electrical vehicle charging, telecommunication system. So all these are the best applications of Vienna rectifiers. Generally, various types of converters are used. I will go through the in short. Uh, Diode rectifiers, in which diodes, bridge rectifier, the bridge are for diode this way. These are in such a way supply are signalized. This is called bridge type, and in this case, this type of bridge rectifiers are used to convert the buck boost converters in electrical vehicle charging. ACPIC type is converter in which the system controlled by intelligent controllers, which improves the settling time. That is 0.3 second, which are generally mentioned. Thereafter, three-phase bridge controller rectifier, which is used for direct power controlling. The power converter used for low power direct controller DC type of conversion is required, used for this. Three-phase control rectifier. The power converters are used for renewable energy power conversion. Thereafter, three-phase control rectifier DPC SVM, that is this is called hybrid or combinations of both. The voltage control with fuzzy logic controller used in this case motor driven applications. This controller used for inductions also. Now voltage oriented controller. The operation of AC to DC power converter only depend on implementation structure. The operation of the oriented control, voltage oriented control Voltage control voltage is a system of voltage controller and current algorithm of auto independence, which is positive. The positive SRF controller used for the clock SRF is using the frame. Due to the disadvantage, the PI controller adequate is used. Now the next we go for advantages of this. Advantages of this Vienna rectifier. Uh, This reduces the harmonics as already mentioned, improves the power factor, improves the stability of the system. Then application where which we can use the application is that this can be used in welding power system. Welding welding is used for generally joining the metals uh, like um, iron, GI, galvanized iron, and such materials. We can say copper welding. Further, there is aluminum welding, but rarely, but majorly GI, MS, copper, such like metals. In order to join these, the welding is used in which high current needs to be produced. Thereafter, another application is that in data controllers, where number of electronic circuits are used, and power consumption in this such center is very high. Current required in this such cases is also very high. In such cases, we can use this Vienna rectifier circuit or church charging stations. Thereafter, telecommunication power system. In this case, in telecommunication, the signals needs to be transmitted for long regions, long area, or we can say long distances. In such cases, high current is necessary. In order to generate such high currents in telecommunication system antennas, the power transmission, the current power also requires high. In such cases, we can use this application. Thereafter, in aircraft system, initially during takeoff and landing, the high current, high power is required for short flight. In such cases, we are able to use this system. Thereafter, most important is vehicle charging station, in which high power required for short period in order to charge the batteries. For very short time, charging are necessary in battery system, so that's why these are necessary. And these much are the thereafter later the simulation work is. These are the input signal three phase AC system, and these are the simulation setup. Generally, this is works on MATLAB. Physically, still under development mode, so that's are not physically tested. It is currently under MATLAB mode. Thereafter, next, these are the output signals. Now, these are the conclusions. In this conclusion, in this work, 3-level Vienna rectifier based voltage controller VOC has been designed and experimentally tested on MATLAB. The proposed system has been simulated using MATLAB. So, simulation work is however applicable for DC fast charger for electrical vehicle. The proposed controller for Vienna rectifier focused on combinations of voltage-oriented controllers with PWM phase modulation. In proposed design, reactive and unstable active powers are contributed to input and output filter and the Vienna rectifier. The proposed design also guarantees the sinusoidal current rate, input in reduction. The system power factor maintained at unity level. That is already mentioned that power factor improves. The total harmonic distortions of input current keep less than 5%, there, which is very less harmonic distance THD, but we can say THD, which IEEE 591 standard. The benefit of proposed controller conventional PFC power factor control correction controller has been demonstrated by simulation experimental and power factor. The Vienna rectifier is the now the next references. These are the references taken. These are the references under which the proposal work or presentations work. And last one is thanks. Thank you so much for giving opportunity to me present myself. I'm very much thankful to Madam Pallavi Madam which assisted me. Further, I am also very much thankful to IMCCRT team management for 2023. They have given me opportunity to present myself. Thank you so much.